Good afternoon, all. I want to believe that we are all keeping safe. And I'm looking forward to seeing us again very shortly. In Jesus' name, amen. Today, we're going to, first of all, introduce what we are doing, and then we just need to run through what we're supposed to be doing this. Okay, I want us to touch base with the whole concept of building information modeling. We need to have a clear understanding of what we are doing and what is expected of us as architects, and then the possibilities that are available for us under this platform. Now, we all know that the digital technologies are changing the way we live, think, learn, and conduct businesses across the world. And in fact, information and communication technologies have completely changed the way architects practice their profession. And building information modeling, it came as a solution for the architecture, engineering, and construction industry, as the AEC industry, for improved communication and performance. You know, one of the challenges that confront us as architects is how can I effectively communicate my design ideas to a host of different classes of audience, beginning from the clients, beginning from your co-professionals in the AEC industry, and then other specialists, other vendors that might be involved in the project. You know, we need to look, how do I communicate with these people effectively for better performance? And beyond just communicating with them for better performance, how do I take advantage of these tools to make my work better? So these are the things that we'll be looking at in details. Now, BIM, it can be defined as the process of creating, using, and maintaining digital information for the integrated design, construction, operation, and maintenance of building. Simply put, BIM is the means by which everyone can understand building through the use of a digital model. I will explain this in details now. If you look at this definition, it says that BIM can be used for the following purposes. I want you to know this, for the following purposes. And I want you to understand that all that time you see before your system, you're using Revit, what interests you is how you can produce 3D impressions or stuff like that. That is way, way beyond what you can do with is way, way beyond that alone. Now listen, these tools are used for the following purposes. Take note: for the design, the construction, the operation, and the maintenance of buildings. Did you get that? For the design, the construction, the operation, and the maintenance of buildings. That is what you use these tools for. Because you are supposed to add information to a digital model that explains your design intent. And to the contractors, to the construction professionals, that information should be adequate enough for them to take down your digital model and go to site and interpret that your design intent effectively and construct the building. Now, that same digital model can be given to facility managers, and it can be used for the operation and maintenance of buildings. That digital model provides details, all kinds of information that can be easily accessed for the maintenance of that particular building. You know, possible, even in terms of live performance analysis or building performance. You can have sensors that are fitted inside the spaces, and they can read real-time data of how that building performs. And that information can be looked back into the design process and used for better design and better performance in the future. Now, we need to look at what we consider to be the key features of these tools we're using for our design. One of the key features is that it provides the information content that defines a product. That's your building. And then it also gives product properties such as thermal performance. Meaning, as you are designing, as you are going to those your family folders and you're picking each element that you're using for that your design, that the properties that is associated with those elements in real life are embedded in that your digital model. What am I trying to say? Take a wall in your building. That wall has its load-bearing capacity. That wall has several other, you have thermal capacities, thermal properties, different things that are embedded in that wall that you can easily extract. Now, in that same model, assuming you have a door, the thermal properties of that door, the fire ratings of that door, they are embedded in that door that you picked and placed in your model. And the beautiful thing about these properties that are embedded in those building elements that you're using is that you can now take that your digital model with all those building elements that are already inside it, with all those properties that are associated with those building elements. You can subject that you're building a digital model to certain queries. You can query the lighting. You can query the temperature. You can a lot of other every single question that you ask about the building in real life. You can take that digital model and then profile those things on that model. Now, that same digital model, it provides the geometry that represents the product's physical characteristics, just like I was trying to explain now. The thermal properties, the fire rating, the load bearing capacity, every single thing that is embedded in any kind of building materials that you're using, that one that is in that your model, it has the same properties. And that is because of those properties. That's why you can subject it to different kinds of analysis and get results that you can use to make an informed decision in your design. Now, that same digital model that you have, it provides you with visualization data that gives that your design a recognizable appearance, meaning the exact thing that, the exact way you want that building to look like, the exact way you want the building to appear in real life, that in that your digital model, you can assign those properties, those elements, whatever it is, on that model, and you can be able to have an idea of what the thing will look like at the end of the day. And now, we also need to look at that same digital model provides you with functional data. Such as detection zones that enables the object to be positioned and behave in the same manner as the product itself. For example, you're designing a house for altar, for example. And then in your digital model, you can take that your model and come to altar through Google Map, plant that you're building on that exact location where you want that building to, where that building will be constructed. And when you do that, the weather data that is associated with that particular environment will read automatically. That is, you can access them automatically, and then you can subject that digital model, that your design, you can subject it to certain queries that will give you a real life idea of how that building will behave in real life, because you want to build in Ota. And then on your computer, you plant your building in Ota through Google Map. And immediately you do that, Autodesk, they have what is called weather data. They have weather data that is associated with different areas of the world. And once you have access to that weather data, you can leverage on that data and do your design. Meaning that if you're checking the temperature in that your design, it will be behaving as if it's in real Ota. If you say 8 a.m. in Ota, it will behave as it's real 8 a.m. in Ota in real life. If you say whatever time frame that you indicate you want to profile on your design, it will behave like it in real life. So inside that model, the functional data that will help you to do this is available. Okay. Now, I want us to look at the key benefits. I want us to look at the key benefits. The key benefits of BIM is that it gives us opportunity to do analysis of structural and energy performance in the design phase. You need to understand that most of the things that we do in design, we might say that most of them are based on residual knowledge. So how wonderful will it be that you can profile your design and subject it to all kinds of analysis under different kinds of conditions, and the result that you will get will be as if that house is already built and you're doing it on that particular house. So it's important that you understand as architects, these things are not just for you to use to do your 3D. It goes far much more beyond that. Now, also in your planning and 4D sequencing and conflict checking in construction phase, you use these tools to do that. You know, you guys are still in 300 level. As you progress, maybe as you get to your 400 level, MSc1, you will start seeing different kinds of tools, BIM tools that you use for different aspects of the work that you're doing. There are different kinds of BIM tools that you can use for your structural and energy performance analysis. And then there are other ones you can use for your planning and 4D construction sequencing and conflict checking in the construction phase. You know, there are so many things. You need to look at it from the perspective that, let me give an example now. Maybe a 7-star hotel is being built. You need to know that the volume of information that is in that model is massive. And everybody that have access to that your model, they don't need the whole information. They need their own parts. So once they have it, once they have your model, then they can easily extract the particular aspect of information that they need. And besides, when you have that model, there's a particular one that is called the composite model. The composite model is the one that has the architectural design model, the structural design model, the electrical design model, the mechanical design model. They are brought under one environment. They are fused together as a composite model. And then when you have that kind of a composite model, you know, it is practically impossible for you as a human being to take that information and check one by one. For example, okay, I need to look at the structural drawing on all the floors. Assuming in that building you have 125 floors. I will check whether this man is putting his columns where I don't want him to put columns, whether he's placing his columns where I'm supposed to have a window, or whether his column is passing in the middle of a window or in the middle of a door or even in the middle of nowhere. So there are tools you can use as an architect to check those conflicts and determine whether there are conflicts anywhere. And then once you see those conflicts, then you can be able to flag it. You can be able to red flag it and to make for the people that are concerned to make the necessary corrections. Also, this same model that you have can be used for component ordering during the procurement phase. Looking at the size and scale of the vision that I just discussed, can you look at it and say, okay, how do I even get, how do I know, you know, all these designs that I will have here, how many beds? In this design, there are 3 different types of beds that we use for different type of room, different room types in this hotel. So you have to ask yourself, okay, this particular type of bed, how many numbers do I have? If you want to do that manually, it means you have to go to your computer, go to floor by floor and be counting and be checking and be documenting them. But at one click on your mouse, you can extract this information. You can extract these schedules that has the capacity of even giving you the elevation, the 3D of that particular element. You want to check the numbers and the description. So you see, you can take your digital model and you give it to a quantity surveyor. If they know how to use BIM, they can extract the information that are already embedded there. So it's a beautiful thing that at this stage in time of your career, you understand how to leverage on these tools. Also, it can be used in the manufacturing process for 3D printing and machining. We need to understand that the building industry, we are getting to a point where the digital technology will play a very big part in what we do. Because with this 3D printing on an industrial scale, do you know that it's possible for you to print your building parts? Even if it's a wall, depending on the materials for that wall. 3D printing on an industrial scale can print that your building, component by component. And as the 3D printer is printing it, all the things that are embedded inside that particular wall, for example, assuming it's a wall you want to print now, everything that is embedded inside that wall, for example, assuming that you have some pipes that are running inside that wall, you have some electrical pipes that are running inside that wall, you have some mechanical pipes that are running inside that wall. As the 3D printer is printing it, if those information are embedded in that model, and the 3D printer will read it and then provide that information. Also, also for, just like I tried to explain earlier, for facility management, knowledge, and updating records of events in the use phase, what the building is being used, the people that are managing it, they should be able to have a database that tells them every single thing that is in that building, every single material that is in that building. When anyone is removed, once they go back to this document, they can be able to know that this thing is supposed to be there, is no longer here. So in facility management, they leverage on BIM tools to do their work also. So you see, as an architect, anytime you are comfortable with a design scheme, when you sit behind a system to design that particular building, you need to know that at the end of the day, these key benefits, these key features that has been listed here can be profiled on that design that you just did. You can analyze your structural and your structural, the structural integrity of that building. You can analyze the building in terms of energy performance. You know exactly what is happening. At the end of the day, if I'm looking at energy, what is the level of illumination in this interior space? This building that will be built in altar, this building that will be oriented in this way, okay, using this type of building envelope, maybe glass, maybe wall, maybe small windows, maybe large windows. So what happens? How would the lighting impact on the interior space? If this are if in this my design, you can check it. And as you're checking it, you are looking at the elements that you use for your design, and at that point you can say, okay, I don't want this. I don't want this. This will give me a better performance. This will give me a better performance. You can look at lighting. A particular space can be used for a particular purpose. For example, a space that is being used for maybe for high detailed work, maybe an architectural studio. You should know that the level of illumination during that in that space should be very high, even for natural lighting and for artificial ventilation, should be very high. So you can be able to, on your design, check what is the level of illumination, what is the level of lighting. And once you are checking those things and you're looking at it, you can be able to know whether you're within the range of what you want. If you're not within the range of what you want, then you can start making changes until changing the different elements and components that you use in the design until you get exactly what you want. Maybe before this class ends, I need to play a construction sequence we did for a particular project so that you guys understand how this thing can be used for planning and for construction sequencing. You know, if you look at this information that we have here, it just tells us about who is using BIM and what tools are they using. What tools are they using? When you look at architects, you look at Revit, ArchiCAD is a BIM product, Magic Card, Vectorworks Architect, there's one Digital Architect, Energy Plus, Ecotet Analysis, Navisworks, Bentley Architecture, Katia. Katia is the one that was used by Frank Gehry and the rest of them, the people that started designing in the digital realm. They were the people that had access to this. Katia is also used for aircraft manufacturing and stuff like that. And then you look at Green Building Studio. Green Building Studio can be used for energy analysis and the rest of them. And then quantity takeoff. Quantity takeoff can be used to generate quantities on a project, meaning that you can hand over this information to anybody and can be able to generate the quantities of that particular project for you. Assuming that you're the project manager of that particular project, you can use these things to be able to check whether the information they're giving you is accurate or not. And then for the structural engineers, there's one you have the RAM steel, Revit structures, take care structures, and the RAM steel Bentley. And then for services engineers, they have the one they call Fanhead VAC, Green Building Studio, Ecotet, AutoCAD MEP, Revit MEP, ABS. As a matter of fact, under service engineers, because you can say, okay, majorly what they're looking at in terms of energy analysis or energy analysis and stuff like that on a building. Today, there are more than 180 energy simulation tools that are in the market now. I mean, 180. So it depends on the particular aspect that you want to profile in your project that determines the one that you will go for. Oh God. What is this? Okay. So for contractors, they look at, there's a one called Constructor, Innovia, Timberline, Navy's work and quantity takeoff. You can see that some of them, they are, are not used by one particular profession. Some of them can be used by 2 or 3 of these professions, so they overlap. And then the fabricators, they use things like Solibri Model, Checker, Katia, Card Pipe, and Fanhead VAC. So one of the things that is key in most of these tools and why people decide to go for things like go for Autodesk products is that you need to look at the interoperability between one tool and the other, which means once an architect does his work, the tools that are being used by the structural engineer, can you read that architect's file? The tools that is being used by the services engineer, can you read that architect's file? The tools that are being used by the contractor, can you read that architect's file? What about the fabricators? When we talk about the fabricators now, mainly we're looking at 3D printing on an industrial scale. You know, when they have access to your tools, do they need to do whatever before they can be able to use it, or can they just plug it into their system and it will read that your file and then they can extract information from it? I want us to look at this. This gives us an overview of what is in this concept that we are embarking on now. You can see that in the center, that's where you have the composite model that contains the whole information that is needed for this particular project is here. So now, from this same digital model that you have, you can extract your 2D drawings, your plans, your elevations, and your sections. That is the one you call working drawing. You can extract them easily. And then you need to also look at your 3D visualization. These ones, you can extract them from the architectural model. And then you also need to look at your 4D simulation. You just talk about construction sequencing. Construction sequencing that you can easily, extract from the composite model. Then you need to talk about 5D. 5D talks about the cost planning. And then you need to look at 6D. 6D talking about energy and lighting analysis, talking about sustainable designs in the project, being able to look at it and then, take advantage of the weather data for that environment and design the facility and profile the facility in terms of functionality. And then when you talk about 4D, 7D, sorry, that when you talk about facility management. From that, you can extract your schedules, your quantities, your fixtures, fittings, your furniture, and for procurement, all those things, they are embedded. They are embedded in your model, and the information can easily be extracted based on a click of a button. And then inside that model, you can do your collision checking. Because why these things are important, why they are necessary, that there are some things that you don't start talking about when you started building. Assuming that you have spent, maybe you are working on a project that is 50 billion naira, and by the time you have spent 5 billion, that's when they now discover that this thing is supposed to be there, or it's not there, it was omitted, maybe because we didn't see it, or we're waiting for this. Something can just happen. And what will be the result of that? It means that you have wasted 5 billion naira. Which means if you have to do that work and do it the way it's supposed to be done, you need to break up these things that you have done to introduce something else that will help the thing to function effectively. So it's important that these things, especially this collision detection, is done at the design phase before you go to site. So that if there's any changes, if there's any correction, if there's anything that has to be done, it can easily be done on your model. But you see, when you have your 2D drawings, maybe you sit down in AutoCAD, do your work in AutoCAD, you print your site plan, print your floor plan, you print all those things. Assuming you're working on a 7-star, how do you profile all this information? Maybe you have several hundred sheets of drawings for that particular project. And if you want to read all of them, you read them one by one. How many people are going to do that? How many architects are supposed to be working in that company to be able to be focused on one particular project? You know, in a firm, you can have 3 or 4 or 5, 6, 7 different kinds of projects that the firm is working on at a particular point in time. And then, if you're not on this platform, you should know the number of people that you need to be able to do that work. So these things are key. These things are very, very important. So this is an overview of what you are expected to know in terms of the tools that you're using for your work. I want you to look at what we have here now. in the course of your work as an architect. These are the things you do. You plan, you design, and then the building is constructed, and the building is operated. So at each of those phases, how many of them are interfacing with each other? What is being done at each of these 4 core areas of the building life cycle? Begin with the planning. You need to look at the existing conditions. That means you're working on a site. What kind of a site do you have there? Is there a level grant? Is there land on a topo survey? Maybe, first of all, you need to model that. And you also need to know where is the location for this building? How will the conditions of that particular location impact on this particular project that we're working on in terms of weather? In terms of also the conditions of the ground. Is it a solid ground? Is it a marshy ground? Is it the water? Is the earth loose? All those informations are what you extract from the sites, and then you do your preliminary cost estimation, which means even before you start a project, you should know where you're headed, unless your client tells you that there's no budget limit for this particular project, so you can go here where you are. But then, if there is a budget limit, you should be able to plan within that to be able to make sure that you don't exceed the budget. Because these things are very, very key. Imagine that you're working on a project and we were not considering budget. By the time you start, the man is not able to complete the project, or the money is not available, or something just happens. You discover that you did not do what you need to do as an architect or advise your client properly. Then you need to look at your planning, even in the design. Are you planning the design in phase, in the building in phases? If you're planning the building in phases in the design, how do you do your design so that, okay, they will do this one this year, next year they do this? How do they relate to each other? Even when one part of the building is functional, if they want to do the next one they're going to do by the side, how does it relate? How does it interrupt the activities, the functions in the existing one? How does it interrupt? On the external context, in terms of movement, bringing trucks and all those things. So some of those things are important in the planning phase. Then to be able to program it and then analyze your site. Under design, you look at the design authoring, structural analysis, lighting analysis, all those things that we mentioned, energy analysis, mechanical analysis, several other engineering analysis that you need to do, LED evaluation that you're building. Does it respond to a LED classification? So all those things are things that you need to also consider. You need to look at, in terms of code, the standard that are being used for that particular area. Are you meeting up with the standard? You can be able to, at a click of a button, check your design based on the standard you're profiling it for, to be able to know whether you're doing the right thing or whether you're way off and you need to go back and correct it. And then you look at the 3D coordination. 3D coordination overlaps between design and construction. So it's very, very important. You look at site utilization, planning, look at construction, systems, design, look at digital fabrication, like I said before, 3D control and planning. And then record model. Record model is just like the as-built model of a particular project. By the time, sometimes when you finish, when you set a design, when you finish, it's not the same thing. Something might have changed due to cost or due to availability or any other thing. So you must have a record model, and then you'll be able to have from that model, you'll be able to sequence your maintenance scheduling. Look at the building systems. You can be able to analyze it even at the operational phase. Then look at asset management, space management and tracking, and then you also need to look at your disaster planning. When you look at project. How do you plan for disaster? If anything happens here, what happens? What are the things that are indicated in terms of to help mitigate effects of disasters? So some of those things you need to look at them carefully. I think for now, we'll stop here and then take your questions for today. Then I just want to see if I can play a video of a construction sequencing of a particular project. I'm waiting for your questions. So. Your questions, please. Ask me your questions because I have so many for you. Still waiting. Huh? Oh. I'm seeing some questions. Some people were asking if SolidWorks is a BIM tool. SolidWorks is a BIM tool, but SolidWorks is not meant for it's not meant for architects. Sincerely, but I know that your CIT classes some times back they were forcing people to do it, but it's not compulsory for architects to know how to use SolidWorks. So what we just did here is to show us the tools that are part of BIM tools. ArchiCAD, yes, it's part of BIM tools. So whether ArchiCAD is outdated or not, it's not what I cannot be able to answer that. But one thing I know is that BIM tools under Autodesk are the industry standards globally today. Not that they are not the only ones that have BIM tools. ArchiCAD is one of them. Bentley architecture is one of them. Even in China and Japan, they have some that they're using it in their client there. But the industry standard globally is Autodesk because of the interoperability between each of their tools. Somebody's asking here, is AutoCAD preferred to Revit while designing due to its compatibility with other softwares? Revit is compatible with so many other softwares. Don't forget that Revit, you can also convert Revit to AutoCAD. So you cannot say that the truth of the matter is that at this time and age now, the world is moving. Even with this pandemic that is confronting the entire humanity now, the world is moving. And AutoCAD, as a matter of fact, is a 2D application. It has some 3D functionalities. But I want you to understand that it is not a BIM tool per se. It is not. So the things that you can do with BIM tools, you might not be able to do it with AutoCAD. So it's good for you to, AutoCAD forms like a basis for you to go into this deeper knowledge of design technology is important. You know, there are some things that you might just want to do quickly, just do it in 2D drawings, do it quickly in CAD and leave. But when you want to model, and that model, you assign properties, assign parameters to it, what they're going to use will not be, those ones will not be AutoCAD. It must be a 3D modeling tool. Thank you. Any other question? What's this? Somebody is coming now. Okay, get it. I'm muted. I think I did. Somebody is asking, why is Revit the industry favorite compared to ArchiCAD? Well, you need to understand that Revit has interoperability with a lot of other tools, but ArchiCAD does not have that. Even though, you know, the people that make ArchiCAD, they are called Graphisoft. The people that make Revit, they are called Autodesk. Autodesk has a lot of tools, so most of their tools work with each other. But sometimes the tools, when you work in ArchiCAD, for you to be able to take it to another level and use it there, is a little bit challenging. So maybe that's why people prefer to go for Revit as an industry standard. So I'm still waiting. Okay. I'm seeing some other questions here. Somebody was asking what are the limitations that I have faced in terms of using BIM in practical situations. One of the challenges is that you are on their platform and your fellow professionals like structural engineers and MI engineers, they're not on that platform. So they will want you to convert your work to CAD before they can use it. And if you want to do project management, maybe, doing your work in a BIM-centric, design process, meaning that you will want the structural engineer to give you his own model in Revit, the electrical engineer to give you his own model in Revit, mechanical to give his own model in Revit in such a way that you piece them together. It's a little bit challenging. Because they are not on the same page with you. So one of the things that really need to be done seriously in our country is that engineers, even from the university level, they should start knowing how to use these tools so that tomorrow they can easily collaborate with architects in practice. Someone is asking again that you can, that I said that you can input your design on the actual site using the Google map, but is the topography is considered. Topography, as a matter of fact, is that if you want to place the topo of your site, the first thing that you need to do, as a matter of fact, is to get the topographic survey of that particular place. And with the topographic survey of that particular place, then you model it, and then you take it to that environment where you can now use it. I'm trying to get the video that I want to play for you guys. Let me look again. If I can't get it now, then we'll do it at another time. Let me confirm for the last time. I think I'm just end the class now. Can't find the video.